Good evening, everyone. This is Asterix Code, and I'm explaining you the problem B, minor reduction of today's educational round 121 code forces div 2. So, this is my channel. First of all, please subscribe to it, and this is the solution for the first video, which is premiering now. You can also watch that, but let's jump into the problem B. So, you are given a decimal representation of an integer x without leading zeros. Okay, so you have to perform the following reduction on it exactly once. So we have to perform an operation which is reduction, and we have to perform it exactly once. So we have to take two neighboring digits in x and replace them with their sum without the leading zeros. Okay, if the sum is 0, then we will represent it as a single 0. Okay, so for example, if x is equal to 10057, the possible reductions are, okay, let me explain you this problem. This is simple. So the problem is, so the given number is, suppose I'll take this example itself. So we have this number 10057, and what we can do, the possible reductions in this number are, we can just choose the numbers pairwise and just replace them by their sum. What this means is, suppose I choose first two numbers, so I can replace them by 1 plus 0. This is 1, so I can replace them by 1, and the number becomes 1057, right? 1057. Or what we can also do, if we have taken these two numbers, the number could be 1057. Again, these two numbers same. If we have taken suppose we have taken these two numbers 57, then this could have become 10012. So these are the possible numbers, and if you take 05, then answer will again be 1057. So I hope you have understood up to this point, because this was quite simple. So at the end, the question is asking us to find the largest number that can be obtained by this procedure. So definitely, if you observe, this is the largest number in this case, which we can observe by performing this reduction once, right? Yeah. So the problem statement is pretty much it. So I'll just jump into the approach, because that will be the only possible way to explain it. Yeah. So I can take two cases. Okay, I can take two cases in it. One case is this one. One case is 10057. In my approach, what I did is I just stored I just stored the pairwise combination of these numbers. What I mean is, I just stored 10, 00, 05 and 57, something like that. I just stored pairwise in it. Okay, and after that, when I am storing this, okay, let's observe one thing. Okay, let's observe one thing. What is the smallest number which, if we take combination of those two numbers, then the sum won't affect the size, or I can say the length of the given string. What are the two smallest numbers which I can take which does not affect the length of this number? So definitely it can be 28. Why 28? Because its sum is 10, and it's the smallest possible two digit number, which again remains two digit after their sum. So 28 will be the smallest of all, right? So it's a quite simple approach, quite simple thing to observe here. So when I was making this array, and this array I named it check. Okay, I named this check, and I created like that. So when I was creating it, I just took a check whether which number, or I just check which index corresponds to the pair of digits whose sum is greater than or equal to 10, because 10 will be the smallest two digit number. Yeah, right, the smallest two digit number is 10. So 10, the sum is 1, so I won't take it. Similarly, sum is 0, sum is 5 here, and the sum is 12 here, and this is greater than or equal to 12 at this index. So my L was my lower bound. I took a variable L and an R was the lower bound, and L was the lower bound and R was the upper bound. So 5 plus 7, 12, and L will be updated by 0, 1, 2, 3. So L will be my 3. L will be updated by 3. That is my lower bound. Why lower bound? I'll tell you in my next example why I have to take two bounds here. Okay, L was my lower bound, and my lower bound becomes 3, because at index 3 I have a digit. If, okay, 0 1 2 3, at index 3 I have two digits. If I take sum of these two digits, then the length of my overall digit won't be affected. And if the length of my digit is not affected in any case, then it will be the largest possible digit. Okay, largest possible digit, because in any other case, if you see, length of this number is 4, length of this number is 4, oh sorry, length of this number is 4, but length of this number is 5 and it is the largest, right? We in order to make the largest, we have to first try to keep the length of the digit same. So yeah, it's okay, it's over. So you understood the lower bound, right? Starting from the left, we are taking the first element whose sum, first element pair whose sum will be greater than or equal to 10. So it's clear, we are taking the lower bound. So yeah, similarly with the upper bound, in this case the lower bound and upper bound coincides, because if we check from this side, then again this would be my this would be my upper bound, because only this is the pair which corresponds to the sum greater than or equal to 10. So my upper bound will also be equal to 3 in this case. So this was a case where L was equal to R. So let me take another case. So if I take 1 2, I just skip the numbers in between. I take 5 6 here, and I take 7 8 here. Okay, so this is my number. Or I can just skip the first two digits also, in order to make the implementation easier to understand. So what are the possible combinations? First is 35 or 35, not 35, because this is a string. Remember, this is a string. You cannot take it as an int or long long whatever. So you cannot take it, so it's a string, because the constraints are 10 power 2 power 2 into 10 power 5. So it goes beyond every storage limit of every variable type. So this is a string. Remember, this is a string. So 35, then the second one is 56 5 6, sorry. So it's 6 7, and the last one 7 8. So in this case, what happens? What is my lower bound? First of all, will this be my lower bound? No, because 3 plus 5 is 8 and this is less than 10. 5 plus 6 11. Yeah, 5 plus 6 11. This is greater than equal to 10. This is greater than equal to 10. So this is greater than equal to 10, and so my L will be 1, because at index 1 I have a pair of digits 5 6 which has a sum greater than or equal to 10. So yeah, L is 1. Now start from the right to left. Start from the right to left. Okay, I'll start from the right. So I arrive at 7 8. Now 7 plus 8 15, greater than equal to 12, greater than equal to 10, or greater than equal to 10, right? So my R will be updated by what? 0 1 2 3. So my R will be 3. So this is the case where L and R are just different from each other. So we have two possibility, whether we can modify these the number at the position L, or at the index L, or we can modify the number at index R, right? We have two possibilities. Now let's observe. So first of all, what I did is I just checked whether if I do modifications at index L or I do modifications at index R, then which would be my better answer. But it turns out that at every scenario, the only possible answer will be if I make the updations, or I will make the updates in the index R. So it is always that case, because if we make updates at 5 6, then this number will become what? This number will become 3 1 1 7 and 8, because 5 plus 6 is 11. But if I make updates at this index at 7 8, then this number will be 3 5 6 1 and 5. So which one is the better answer? Which one is the better answer? Definitely this is the best answer. This is not. So if L and R do not coincide, then we can make updates in the index R. Or these two cases can be combined. If we just check if we just iterate over this check array. This is the check array from right to left. So whatever my first occurrence of the pairwise integers whose sum will be greater than or equal to 12, then I will just make the updates over the index r. So this is my answer. Let me show you my code. Some of the part is commented down because I didn't make it quite good. So I just first make a quick update to it. Okay, so I just took lr. There was no need of l, by the way. So if I just remove this l, I'll just remove the unnecessary stuff. So what I did here is I just removed this l. Okay, I don't need this l. I only need r, because even if l and r coincides, then only r variable can do the whole thing which these two variables were doing. So I don't need r, I don't need l, so I can remove -1 here. So okay, now r is being updated here. So if l is equal to -1 and r is equal to or I can just check if r is equal to -1, then I'll just print what this means. R is equal to -1 means if there is such case, which was the second test case, I guess. Yeah, it was the second test case. Yeah, 90. So 90 is the case given to me, and what I can do is, so this is my only pair, right? So if I iterate from the right, so its sum is 9, and which is less than equal to 10. So my r won't be updated and my r will remain -1. So in that case, if r is -1, I just print the sum of the first digit and the second digit, right? Sum of the first digit and second digit, that will be my 9, and I will just print this down. So yeah, I just printed. And if some array is present after that, yeah, here is the scenario. Yeah, I just print the whole of the array. Now if l is equal to r, and I think this should not be the case. I don't need this part. I don't need this part. I can just take the else here. I don't need to check if l is equal to r or not. Yeah, this is pretty much it. This is pretty much it. Let me just test this first. And yeah, it's working. Let me just, if this works, then I think I'll just explain to you that. Okay, let's just submit. Yeah, it's working. Told you. Okay, I hope you understood that. So now it's pretty much more readable. So I just make a check array, and I just take an upper bound to check from the right side. Now I just make this check array by taking pairwise elements s of I plus s of I plus 1. That will be the string, of course. Now I'll just take an array, take a loop from right to left, from n minus 2 to -1. And why n minus 2? Because the pairwise things, you cannot take the n minus 1 array, because n minus 1 plus 1 will be out of the bounds. So I have to take n minus 2. So if that is it, then my upper bound will be updated and I will break this loop. Then yeah, if r is -1, that means I don't have any such pair whose sum is greater than equal to 10. So I just print this, the sum of the first digit and the second, and the whole of the string as it is. And if I find such element at the front, at the right side, starting from the right, I just update that by taking the sum of those two integers whose sum was greater than equal to 10. So this is the part that taking the sum, and I'm just copying the string part before that and the string part after that. So yeah, and at the end I just print the string. I just updated the string in itself, and I just print the string. So yeah, this is pretty much everything. So please, I want to see that number 200. Where I want to see that number 200? Here. I want to see this number as 200. Okay, make this number as 200. Yeah, goodbye. I just meet you in the third video. I'll make the video on the third part. Bye.